Hello, hello. This is the My Artifact episode number 4145. Today's date is 8th of July 2026. It's been almost like a morning at 9:20 p.m. Not p.m. Sorry, a.m. Yeah, 9:20 a.m. Morning at 9:20 a.m. All right. Usually I record artifact, video artifact in the morning, but I kind of like I just had a breakfast, a very heavy breakfast, and I don't want to kind of like a sit, so that's why I'm kind of like a walking. You cannot able to record video artifact while walking, so that's why I'm recording audio artifact episode. Whatever. Let's just jump into the question. All right. Yeah. All right. So question is, what about environmental cost? Oh, that's a really good question. All right. Yeah. First of all, what exactly is this question, and why am I asking this question to myself? I wanted to build app called My Artifact. What exactly is this application? When you write the diary every single day, you cannot able to be write the diary the way that you wanted to. The reason is that your thought process are actually much more faster than your writing speed. Your writing speed is slow is because of you need a pen, you need a paper, you need a convenience, and even after that you need to put lot of amount of effort to write something. And because of it takes so much amount of effort, almost no one is actually writing a diary, like nothing negligible. But what if instead of writing a diary, what if we could record a diary, like a audio record a diary? The stuff that you are kind of like listening right now, this is my audio diary. I called it My Artifact episode number 4144. I'm doing this thing for past 11 years. I am doing this thing every single day. Because of writing a diary is a self-reflection process, so as a recording a diary, so as a recording artifact is a self-reflection process. It add so much amount of value inside of me. The person that I became today, the person that I will become tomorrow, it is all because of artifact. The amount of value it add inside of me, I wanted to share this value. How do I supposed to do that? By building an application. My application is somewhat something like a YouTube platform. In a YouTube, you kind of like a somebody upload your video, other people kind of like a sees a video. Same thing, you record your artifact, upload your artifact in the artifact platform. Other people kind of like a listen your artifact. By the way, artifact is an audio-based platform. There is one catch is that your identity is always kept hidden. Like my real name is Saurabh Avthare, but my artifact handle name would be Prozac 1943 or something else or whatever it is. Okay, yeah. So this is my application. Before I wanted to build this application, I wanted to aware of all the possible consequences. So I went to ChatGPT. I tell my idea, tell him that he suggests me hundreds of all the worst possible consequences. ChatGPT kind of like suggests me all the worst possible consequences in question. This is one of those questions. Now regarding about this question, the question says that what about the environmental cost? Okay, what is exactly the environmental cost? Environmental cost means like that if you are running your business, like your application is a kind of like a somewhat something a business. So if you are running a business, are you kind of like creating any kind of like something pollution or things or that and that and that? That's a kind of like a really like a basically is this thing that when you are running a kind of like a particular business, then environmental perspective you have to think about that. Okay, yeah. But dude, my application is not kind of like a creating any pollution. I am not kind of like a somebody building a factory or things and that and that. My application is just like a kind of like a just audio application. It's on the mobile phone. The people will kind of like simply record the artifact and things and that and that. So like there is no pollution, like there is no kind of like a things, right? Well, technically no, yeah. Sorry, like from visual point of perspective no, but technically yes. Every application is a kind of like a doing a pollution. Take example, let's just say OpenAI is a kind of like a application. ChatGPT, okay, ChatGPT, OpenAI, same. Okay, so does OpenAI or ChatGPT is a kind of like a doing any pollution? Well, practically or visual point of perspective no, but yeah, it is like it consumes so much amount of electricity, it consumes so much amount of fresh water and things and that and that. okay, why does it kind of like it takes that much amount of kind of like a power and water? Well, basically it's this thing that the all the kind of like a AI model that you are kind of like a running is actually running on graphics card. Okay, yeah. And a graphics card is a kind of like a very heavy machine. Like it kind of like a gets so much hotter. Like when it kind of like a process, it kind of like a became so much hotter. So basically is this thing, when you have to be kind of like use graphic card for full throttle, you need electricity. And after you kind of like use a graphics card for full throttle, you have to cool down your graphics card too, because it get warm, so you need water too. Okay, yeah. So basically massive amount of electricity and massive amount of kind of like a simply water it really required to kind of like a something come something that key kind of like a cool down the graphics card and kind of like a make sure the entire kind of like a network and process should supposed to happen quickly, right? But also let me kind of like tell you thing, electricity that we could generate it. Okay, yeah, we have kind of like a lot of ways and things and that. What about water? Oh yeah, how do we supposed to be generate the water? Because basically graphics card takes a kind of like a fresh water to kind of like a something like cool down and things and that. It does not like it kind of it does not kind of like a work on kind of like a sea salt water. No, it really required fresh water, and fresh water reservoir are very less on the planet. Almost like a 1% of the water is a fresh water, and possibly it's usually kind of this fresh water is kind of like a consumed from kind of like a river and things and that and whoever the people who are kind of like a living near to the data center, like this is all actually happen in data center. So basically those people are kind of like facing the consequences, like a water kind of like a things, or kind of like having less electricity, or maybe kind of like a electricity prices are kind of like much more higher and things and that. The entire global consumption of electricity, 1 to 1.5% of electricity is only consumed by AI. Just 1 to 1.5% consumed by just AI. Like do you understand what exactly it means? Like basically is this thing, in the world there are millions of factories, millions of kind of like houses, billions of people are kind of like using phones and things and that we have kind of like a billions and trillions of bulb and light and fans and ACs and kind of like a whatnot we have. Oh yeah, but even after we have all those things, they are not kind of like consume that much amount of electricity. But AI is consuming 1%. Like probably you are kind of like thinking that 1%, 1.5% is almost nothing really at all, right? Well, technically yeah, it's nothing really at all, but I'm talking about the entire consumption of electricity from world point of perspective, and in this 1% is kind of like too much by just kind of like supporting only one kind of like a something the faculty of AI and things like that, which is kind of like a very expensive. So yes, so not only the kind of like a chat GPT, but every AI model like a Claude, Gemini, everything is kind of like a consume so much amount of electricity and water and things like that, which creates the pollution. Okay, yeah, which creates creates pollution means like that a kind of like a scarcity, like a kind of like consuming so much amount of electricity. Okay, that kind of like assembly which is like a too much, and water is a also okay, not having a water is also kind of like assembly a deficiency. Okay, and also the radio signals. Okay, yeah, like whatever the kind of like some app that you are using, or whatever the kind of like some the data it transfer from your cell tower to your mobile phone to things and that, which is also consume kind of like some sort of amount of electricity, which is also kind of like a pollution too. Okay, yeah. So what do you mean that like should I kind of like make a such app that doesn't really require a kind of like electricity, doesn't really require water? What do I supposed to do that? Well, you can't solve that thing. Okay, yeah, like it's not, it's a kind of like a things that na ki you have to bear that kind of like a stuff. So I have to be asked this question to myself, is my application is a kind of like a creating such a kind of like a pollution? Well, my entire application is a kind of like a social media kind of like that. Okay, yeah, and no, it's not kind of like a somebody consumes so much amount of electricity things. One of the biggest reason that kind of like my kind of like assembly my application will kind of like consume or creating pollution is Adam, because Adam is a AI. And Adam is not just a kind of like a AI. Adam is just like a bigger than all of those. A chat GPT kind of like a take couple of seconds to kind of like a generate the prompt or generate the kind of like a result, but Adam, no. Adam is a kind of like a very different thing. Adam is a kind of like that key. The processing actually happened continuously, non-stop. Like a basically finding the result on one prompt takes maybe a couple of hours for Adam. Why? Because Adam is kind of like a predicting possibility of future possibility. It's a prediction model. Okay. It's a future prediction model. It could predict the future possibility, what would gonna happen and things and that and that. And because of this thing, Adam has to be kind of like a go through millions and millions of possible consequences of every possible things and that and that and that. It try to simulate the entire scenario, and basically is this thing that key, if I run the Adam on normal GPU, it might gonna took me like so many kind of like a GPUs and things and that and that, and it's not really possible. Yeah, because the processing required for Adam is too much, too much. Okay, yeah. So normal computing, Adam will not gonna work on normal computer or normal classical computer. No, Adam only and only like it's not really that Adam cannot able to work on classical computer. It work, but it takes so much amount of time and process and things, and from economic point of perspective, that is not feasible. So only way to utilize the Adam by using the quantum computer, or quantum computer is only one way to kind of like a something Adam will kind of like a run. Now what's a quantum computer? A quantum computer is not a classical computer. Okay, it's a very different form of computer. By the way, is the quantum computer is a kind of like a upgraded version of classical computer? No, that is the kind of like a thing you have to understand. No, a classical computer is a different breed, and quantum computer is a very complete different breed. Okay, yeah, it's a kind of like a lion and tiger. Okay, completely different. Okay, their shape, size, visual, everything is completely different. So quantum computer is not an upgraded version of classical computer. No, nothing really at all. Quantum computer are such a computer where kind of like a very unique process actually happen. Like a quantum computer is not meant to be kind of like a do the classical things or classical work, like what is actually 2 plus 2 is equal to 4. No, quantum computer is not made for that. And if you try to kind of like give that prompt, probably quantum computer might gonna fail, because quantum computer is not actually made for that. A quantum computer is actually kind of like made for possible consequences or millions or billions of kind of like a possible answers, and find out a kind of like a one possible answer. That is for quantum computer. Okay, yeah. Okay, I'm kind of like going through a little bit of kind of like a technical point of perspective. So I'm just trying to understand. I'm gonna tell you the what is exactly the quantum computer. Then I will kind of like tell you how do I supposed to do that or things like that. Okay, let's start. Okay. So every computer, every classical computer, or classical computer means like that every computer, like your calculator, to your phone, to your computer, to your laptop, or whatever it is, everything that you are kind of like a some digital product that you are kind of like a see, those are the computer, or kind of like a say classical computer. Okay, yeah, like those are kind of like a meant to do perform some sort of task and things and that and that. Okay, yeah. Now basically every computer have kind of like a process information through binary language. Okay, binary code 0 and 1. Okay, yeah, like you kind of like heard that my computer, sorry, my mobile phone is like this mobile phone right now I'm actually holding. This is the Poco X7 Pro, which has a capacity of 246 gigabytes of storage. Okay, yeah, what's the GB? It's a gigabyte. Okay, these are the storage format. Okay, the low format like basically megabyte, then kilobytes, then bytes, then bits. Okay, yeah. And these are the kind of like some essential kind of like some structure of kind of like storing the information. Okay, yeah. 0 1 0 1. Like if I'm gonna say that ki my name is Saurabh Authare, so basically SAURABHAWATHARE. So this is the kind of like a some spelling of my name. Okay, yeah. Now, if I'm gonna say that key convert this kind of like assembly letter into the binary, so it might be look like a 0 1 0 1 0 1 0 0 0 1 1 1 0 0 0 something something something. Okay, yeah. Now, basically, machine understand binary language. It does not understand letter or number or anything. It just understands 0 and 1. Any kind of like information, video, audio, images, text, number, whatever the kind of like information that you have is a kind of like a transcoded to binary number 0 1 0 1 0 1. All right. So entire information, like if the machine is a kind of like a processing the information, it goes through binary. Okay, yeah. Now binary is a kind language is a kind of like a somewhat something very like a really good like from visual point of perspective. It's a kind of like that ki 0 1 0 1 0 1. Now the problem is that na ki basically it's this thing like I'm not really sure, like it's a very technical point of perspective. I'm not kind of like giving you proper exact information, but whatever the kind of like information that I have, I'm just trying to tell you. Okay, so basically is this thing that key the 0101 kind of like a format are kind of like a easy to use to calculate, kind of like a simple thing, like a millions of calculation you could able to do in 1 second. Okay, yeah. I'm saying millions of calculation, millions or kind of like a billions of calculation, like probably or kind of like a say billions of calculation is a no, billions is also too much. Hundreds of millions of calculation can able to be do by kind of like a classical computer, hundreds of millions of calculation. Okay, yeah. Okay, if you're not really understanding this possible consequences, okay, have you played game, Call of Duty game, like any kind of like a game? Okay, yeah. I'm not saying a kind of like a Super Mario game. No, it's a kind of like a very simple form of game. A kind of like a kind of like a the new modern world games. Okay, like a Call of Duty, God of War, or kind of like a things and that whatever. If you play, okay, you understand the GPU. If you don't really play, you probably kind of like seen some sort of footage regarding about some people actually playing the games and things and that. Okay, yeah. So basically in the game, okay, every environment or every scenario is a kind of like a bit more different. Okay, yeah, because everything actually happened live in front of you. The bullet flash, the muzzle flash, the kind of like a grenade sound, the smoke, the kind of like a shadows, the light, the building, the NPC actually moving, NPC shadows, and there are kind of like a multiples of calculation that GPU actually do every single second to kind of like a generate the frame. Okay, yeah. And how fast it could generate the frame, we kind of like somebody tell him FPS, like how much FPS it creates, means like that how many frames per second is actually create while kind of like a generating the kind of like a generating kind of like somebody the frames in the video games. Okay, yeah. Now basically kind of like a game developer is a kind of like a already build the kind of like a engine regarding about how the structure look, how the kind of like a bullet flash, how the kind of like a engine flash and everything. GPU is actually process the whatever the kind of like a game developer develop, it process that information on the GPU. Okay, yeah. And because of GPU it kind of like a render that particular image. Okay, yeah. Imagine a kind of like a things that na ki a kind of like a, let's just say a kind of like a painting. Okay, yeah, a painting. So let's just say Mona Lisa painting. A one particular person kind of like a takes maybe kind of like a 1 to 2 minute to kind of like a paint the entire painting, but the GPU has a kind of like a hundreds or maybe thousands of kind of like a some small painter who are kind of like a painting small section of the frame that is called pixel, and when they do that thing, it could paint the entire Mona Lisa painting couple of fraction of second. Okay, yeah. So that is the power of GPU. One particular person is actually painting, that is called CPU. Okay, yeah. CPU is like why not CPU are used for gaming? Because CPU are kind of like one intelligent kind of like a particular person who decides the task but cannot perform fastly. GPU is a kind of like a things, it is a kind of like a stupid. It's not like that kind of like a somebody smart, but because of it has a kind of like a so many kind of like a workers, like a millions and so many kind of like a worker who are calculating things, so they kind of like a do the task very fastly. Okay, yeah. If they kind of like a provide the SOP or a system of process, then they kind of like a do this thing. Okay, so that's why game or game development is, or gaming generation or whatever the game should supposed to be run on GPU. Okay, yeah, and it could kind of like take that thing. Okay, same goes with the AI. AI is a kind of like a things that key kind of like everything, all the kind of like a calculation actually happened simultaneously. So GPU is kind of like a handle that thing. Okay, yeah, like basically GPU is a kind of like a meant to be kind of like a do this calculation probably almost like a millions or maybe hundreds of millions. Okay, yeah, there are hundreds of millions, like if there are like if you're kind of like saying that is a too much big number, but yeah, the calculation kind of like went through so much. Okay, yeah, now when the number kind of like a get too much, like let's just say a kind of like a one kind of like a system takes kind of like a billions of calculation per second, billions of calculation. In that possible consequences, the classical computer actually fail. Why? Because it cannot perform, or even if it try to perform, it takes so much amount of time. So basically the classical computer or supercomputer are kind of like a fail to do this thing. So if you wanted to calculate a kind of like a something like the billions of possible consequences, then you need a quantum computer. Okay, yeah. So basically ask this first. Okay, yeah, is there any kind of like application do we have to kind of like use this kind of like a something the kind of like a something that many calculation, like a like can we able to make a such a game that required kind of like a billions of calculation? Well, technically you can't make such a game that required billions of calculation. Why? Because even if you put so many things in the game, like millions of calculation, it's too much. Okay, yeah, it is already too much. In the millions of calculation, you can generate a very beautiful games and things and that and that and that. Okay, yeah, it's gaming doesn't really required for quantum computer, because quantum computer are not generate for the games. Quantum computer are actually made for something very different. Okay, yeah. Now this is like a I kind of like tell you about the classical computer. Okay, now let's talk about the quantum computer, why it's kind of like a different from classical computer. Okay, so classical computer is actually stored data um, at the same time, like basically it's a thing like a classical computer kind of like a stored 0 or 1, like a what is the value of letter A, it would be 001, right, and it would be always be 001 when I will kind of like a things. Okay, yeah, so basically is this thing, this is the kind of like information, but and this information takes that much amount of space, like let's just say a kind of like a simple understanding. Okay, yeah, let's say a kind of like a letter S. Okay, yeah, so letter S, how much binary kind of like a takes, maybe kind of like a, let's say 01. Yeah, let's say 01. By the way, that 01 is actually kind of like a language is actually coded by the gate. Okay, and gate, nor gate, not gate, and things and that. These gates are kind of like assembly kind of like a tell us that what is that is the number and things and that. I didn't talk about the gates like it's like if I'm gonna talk about the gates, then it would be kind of like a bit more electrical point of perspective, and I will not gonna go over there. It's a very deep over there. Okay, so basically it's this thing, a classical computer is actually store the data one at a time. Okay, yeah, like basically letter A, like sorry, letter S has a kind of like a binary code as a 01. Now basically 01, right, if I change the letter B, it will be 00. So let me tell you one thing, that 00 or 01 does not change. If I want to change, I could able to be changed. Okay, yeah, but that letter, maybe I'm not really kind of like explain this thing very much properly, but this is what it is, a kind of like somebody is this thing that he like basically is this thing that he the like it's a very kind of like a very difficult. Okay, it's difficult. I'm kind of like a try to tell you whatever the information that I have. Okay, so a classical computer kind of like a save the data regarding about the kind of like at the moment it does not change. Okay, but quantum computer kind of like a do the something, it could kind of like a show 0 and 1 at the same time. Okay, yeah, like classical computer kind of like a show only 0 or only 1. Okay, yeah, but a quantum computer kind of like a show both state at the same time, 0 and 1. Okay, yeah, now I will not gonna talk about that how this actually happened and kind of like a interference and covariance and kind of like a simply double split experiment and kind of like a lot of things. It has a kind of like a lot of stuff. Okay, lot of stuff like I will not gonna talk about the quantum computer how it actually happened and things and that. Okay. So basically this is the quantum computer. Okay, a quantum computer kind of like a calculate millions or trillions of calculation per second. Okay, yeah, trillions of calculation. How this actually kind of like a do this thing? Like basically is this thing how this kind of like a quantum computer kind of like a do this thing by because of the kind of like a simply the it has a kind of like a possibility to kind of like a simply save the information multiple information at the same time like a 0 and 1. So if we add the qubits like a bits, then it would be sorry qubits. Okay, then it would be kind of like a multiple like if I'm try to like I'm not kind of like try to explain this thing. It's like I'm not really kind of like a really not good at that. Okay, or in the explaining the quantum computer how it actually works. It's a really beautiful technique. It's like one of the best. Okay, yeah. So basically is this thing that key if I wanted to run the atom on classical computer, it's not really possible. Why? Because atom takes so many kind of like a possible consequences. Okay, millions of consequences. There are so many things because atom is a kind of like a predicting outcome possible model. It is actually predicting the possibility what will gonna happen and things like that. It generate the situation, it generate the kind of like a scenario and run the scenario, and that scenario called kind of like a simulation. Okay, yeah. And that is a kind of like a things when you try to do a simulation, and in that simulation have kind of like a millions of possible consequences, then it really required to kind of like a use kind of like a quantum computer because the classical computer is completely fail. Okay, yeah. So for that kind of like a something like a, for that kind of like a running atom, how do you supposed to be atom should supposed to be work on the quantum computer? Well, right now I don't really knew it. Okay, yeah, but atom is not actually run on classical computer. It only and only run on quantum computer. Okay, yeah. Now if I try to kind of like a run atom on a quantum computer, basically is this thing that key I cannot able to be run the kind of like a quantum computer in the surface of planet of Earth. Okay, yeah. If I wanted to run the atom, I have to be kind of like a make the data center in a space, and only then kind of like a simply that key atom should supposed to be run because a quantum computer required a kind of like a absolute zero temperature. Minus 273 something degrees Celsius, which is kind of like absolutely when there is no kind of like a reaction actually happen, entire atomic reaction actually stop in that kind of like a reaction that is called absolute zero temperature. Okay, and that temperature cannot able to be maintained on the surface of planet of Earth because obviously like we have kind of like a medium over here, like a air medium, like we have atmosphere over here. If you want it, like it's not really that the quantum computer cannot able to be perform in a kind of like a something the surface of planet. It can perform, but it really requires so much amount of resources. Like basically, like as I mentioned, it really required minus 273 degrees Celsius. A normal kind of like a classical computer required to kind of like a cool down, it takes maybe kind of like a 0 or maybe kind of like a minus 10 or minus 20 degrees Celsius. Okay, yeah, or maybe something that it's kind of like a fine temperature for them for the classical computer. But quantum computer, it takes minus 273 degrees Celsius. And how do I supposed to kind of like a provide that much amount of cold to kind of like a classical to the quantum computer? It's not really possible. Okay, yeah. So it is only way to kind of like a do this thing to kind of like a build atom data center into the space. Okay, like a higher Earth or orbit, or maybe kind of like a lower, not lower Earth orbit, maybe kind of like I don't know where it should supposed to be, but kind of like atom will situate over there. Okay. Now another question arises that key how many quantum computer do you really require? Well, basically it's not a quantum computer. I don't really need a quantum computer. I need a quantum chip, quantum computing chip. Okay, yeah, which is actually designed by the Google Willow chip, which is a quantum computing chip, and which is really good. But another thing is that like I'm not really sure about this thing. Like basically it's a lot of kind of like a possibility and things and that. If I wanted to kind of like implement atom in a mass scale, data center is the only one way to kind of like do this thing, because obviously there is no kind of like a methodology to kind of like a something that key like a basically like a data center should supposed to be built on surface and kind of like allow for mass people. It's not really possible. So Adam is kind of like a should supposed to be kind of like a simply work on data center which actually kind of like on the space, okay, yeah, which run on quantum computer. Okay, why space is a kind of like a thing, okay, as I mentioned the temperature, okay, because the outer space or orbit is a kind of like a much more colder. So basically it's this thing, the space is not really that much cold, like basically almost like a 127 degrees Celsius outer space, okay, but it kind of like a somebody is this thing that key if I kind of like a do it, it kind of like consume me very less amount of energy to kind of like a cool down from minus 200 minus 127 to minus 200, which is kind of like a much easier for me in the orbit. But if I kind of like a do this thing on the surface, I have to be kind of like a do this from 0 to minus 200, so which is kind of like a takes so much amount of effort or a kind of like a process to kind of like a do this thing. So yeah, so basically it's this thing that key I have to be kind of like a simply set up the data center on the space where Adam could kind of like perform his task, okay. How many kind of like assembly chipset do you require? Well, I'm not really sure. This is a kind of like a question that I am not sure about this thing. Why? Because of that key um like basically is this thing, do I need a kind of like a some hundreds of quantum chips, or maybe kind of like a one quantum chips is kind of like had enough? I still doesn't know about this particular stuff because yeah, kind of like a quantum chip is kind of like a try to do trillions of calculation, but still the kind of like a process really required for one prompt is too much, okay, yeah, like basically it's this thing, let's just say a classical, like let's just say ChatGPT kind of like takes maybe kind of like a one prompt takes maybe kind of like a only kind of like a couple of token, okay, let's say kind of like a token. So kind of like if I kind of like put the prompt in ChatGPT take one token, okay, yeah. But if I'm kind of like run the same prompt in a kind of like Adam will kind of like use millions of tokens and things and that. Okay, by the way, it's depend on prompt too. Like if you are kind of like seeing that key kind of like rewrite this kind of like English sentence in kind of like a much more better way, then ChatGPT kind of like do this thing much more better way. Adam is a kind of like a design for handling the multiple consequences, like a basically predicting possibility and future and things and that. So it takes so much amount of processing things and that. So maybe a kind of like a one particular user kind of like a takes so much amount of processing power from one chip. And if I kind of like a set as a Adam for mass distribution, then probably I need so many amount of kind of like assembly chips which are, I don't know about this particular process. Oh yeah, okay. And this is a kind of like a future, by the way, because the like basically maybe kind of like a within a maybe kind of like a 5 year you might see the data center, but after the 5 year you might not see the data center on the surface of the planet. Most of the kind of like a data center will be situated at the orbit, okay, yeah, because it is a kind of like economical point of perspective, which is kind of like a much more better, because in the space there is no space, so in the space there is no issue of space because it has a lot of amount of space. You don't really require water because the temperature is kind of like a much more already colder. You just have to radiate the heat from outer the station, which is kind of like a very easy to do this thing. And the resources really required for kind of like a set up the data center in a space, it is too much, yeah, it is too much. But in the future it will be kind of like very less, because of that key the Starlink, sorry, the SpaceX is a kind of like simply the like a reusing the rocket, which is kind of like a really kind of like a better way to kind of like a less the price of kind of like a sending something on space. So because of this thing, probably it will gonna cost very less, and most of the kind of like assembly the AI company will kind of like run their kind of like a model into the space, okay, yeah, they will not gonna run the model on the planet surface of the planet, because economic point of perspective that is not possible, okay, yeah. So same as Adam will also kind of like a run on kind of like a data center in space, okay, yeah. But still and if I do this thing, then the environmental cost would be kind of like a very less, okay, yeah, because I don't really require that much amount of water, and kind of I don't really require that much amount of electricity, because okay, in the data center, electricity is actually forever. Okay, yeah, like basically in the surf space, you have a kind of like a solar panel, and solar panel are kind of like assembly, almost like a whatever the solar panel that you have on your rooftop are kind of like a just 20% efficient, okay, with the sunlight. But when you are put that solar panel into the space, that solar panel kind of like a put the efficiency almost like 80%, 80 to 90%, because there is no cloud, there is no kind of like a things, okay, yeah, there is no dust particle, nothing really at all. The solar panel is kind of like a working 24-hour non-stop, continue generating electricity, and also pure form of electricity. Okay, so yeah, so basically there is like yeah. So the question is that what is actually the environmental cost regarding about for kind of like assembly for the artifact. Specifically at the beginning, artifact will kind of like a run on kind of like a typical like a basically this thing. I will kind of like a make the Atom first, okay, not a simulation Atom, because okay, let me tell you one thing. There is a two form of Atom. Atom is a normal AI model, okay, which could kind of like a run like a ChatGPT, like a Claude, like a Gemini. Okay, it does like a Atom does the same thing. And there is another way, the higher version of Atom is Atom simulation, and that Atom simulation required a kind of like a quantum computer. Now basically is this thing that how do I supposed to do that? That's a kind of like a biggest challenge for me, because of that like no one kind of like a build any kind of like a quantum chip are made. Yeah, the Google Willow chip is actually exist, which can able to perform a kind of like a quantum task. But there is no kind of like a process actually kind of like a made. The Atom is a kind of like a first one to kind of like assembly like a basically credible enough to kind of like use a quantum chip. But I'm not really sure. Talking about this thing at the moment is a kind of like a very much like I'm not really sure about all the possible things. Okay, yeah. Yeah, so this is kind of like this. What if the kind of like somebody that your entire process actually happened through classical computer? Then you don't really require a kind of like somebody like a quantum computer, right? Well, technically not, because Atom simulation or Atom, okay, Atom takes so much amount of processing speed. Like if I can, it's not really that Atom cannot able to be run on classical computer. No, Atom can run classical computer, but the kind of like a result it takes like a basically classical computer kind of like a took me maybe kind of like a something maybe kind of like a hours or maybe days to kind of like a giving the answer. A quantum computer took me maybe kind of like a 3 to 4 minute or 5 minute. Okay, yeah. So this kind of like a massive difference. A kind of like a classical computer kind of like a give me result in 48 hour or maybe 72 hour. But the quantum computer took me kind of like a give me the same result in maybe kind of like a 3 to 4 minute. Okay, so this is a kind of like a assembly the yeah stuff. It's not really that Atom cannot able to be run on classical computer, but still it's not really kind of like a somebody affordable, or it's not really that a kind of like economic point of perspective is right. And also it consumes so much amount of processing effort and kind of like a somebody the water, electricity and things. It's not really kind of like a practical. So quantum computer is the only one way to kind of use the Atom. Okay, so yeah, specifically Atom simulation. Okay, yeah. But at the beginning, like basically stuff that I'm kind of like a say is kind of like a bit more futuristic and things and that. But when you are implementing in real life, there are so many kind of like a possible worst possible things will gonna happen. I have to figure it out so many ways. But at the moment I'm thinking like this is what I'm thinking. I'm not really sure what will gonna happen in the future, because there are so many things. Okay, and also is this thing now I don't want to rely on kind of like a Google quantum chip. Okay, if I'm kind of like succeeded this thing, my first priority task is that kind of like a make my own quantum chip. I don't want to rely on kind of like a Google chipset. Why? Simple thing, dude. Like basically this thing, the control the supply line. Okay, like if you wanted to kind of like somebody the build your business to make sure that everything should supposed to be controlled, so that you will control the every parameter of everything regarding about chip manufacturing and everything like just kind of like somebody the Apple control everything regarding about the. It's not really that Apple kind of like make them Apple like Apple kind of like somebody like basically like it kind of like makes everything like OS and kind of like somebody hardware like sorry, Apple does not make the hardware by itself. Apple design the everything. Okay, yeah. Then it kind of like a given to the kind of like a the retailer vendor, and the vendors are kind of like a make the hardware and things like that. But kind of like a Apple is kind of like controlling everything regarding about that. He design everything regarding about how the app look like, how the mobile phone look like, regarding about hardware and software and things like that. It kind of control everything. And when you have control everything, then you could kind of like a manipulate everything. Okay, yeah. If I rely on kind of like a quantum chip from Google, then possibly it's not really economical point of perspective, it's not really good. And even if the kind of like something wrong with actually happened with me with Google, then possibly is this thing that then how would I supposed to be run if they kind of like say this thing, we will not kind of like give you the quantum chipset, then what do I supposed to do? Okay, yeah, Adam will be useless, right? So yeah, so I need to make my own chipset, but it's a future topic. Okay, yeah, first of all I have to be rely on kind of like a Google chipset. Okay, or maybe whatever the kind of like a quantum chip which kind of like a providing, probably is a kind of like a Qualcomm is a like Google is actually made the quantum chip, Qualcomm is actually making. I heard the news, I'm not really sure about that, but Google Willow chip is actually kind of like exist, it's a quantum chip. I don't know what will gonna happen. Okay, yeah. So if I kind of like make the quantum chip, it would be kind of like a much more efficient way to kind of like simply normalize the kind of like environmental factor and things and that, and that to make sure that the pollution will not gonna happen like happen less. It's not only that the pollution will not gonna happen, it happened, but it would be happen very less. Okay, yeah, as compared to kind of like classical things or classical using of other things and that. So this is my vision, but still it's a very long journey. Okay, yeah. And kind of like things that now it's kind of like a talking something kind of like a really good way, but implementing things is kind of like another topic stuff. Whatever, this is it. I have to bend here, and thank you.